Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating System. In this lecture, we will understand what is deadlock and little bit introduction about this deadlock. Before going that, you all might be aware like we in our computer system we have some resources available. Resources like you can have resources like printer, memory, cache memory, or scanner. These are all your resources. Now, we have resources and also we have some processes also available in our computer. Processes means whenever we have something in our main memory which is waiting for to be executed. Now, to complete that task, sometimes the process may require these resources. Now, who will allocate the resources to the process? The operating system will allocate the resources to the process. So whenever process needs anything, it will request the operating system, and that operating system will check for these resources. If they are available, then the resources will be allocated to the process. That is the general scenario. Now, if this is the case, now let us consider one scenario. Let us consider we have two process. Let us consider two process, P1 and P2. Okay, and then let us consider two resources. Resources like R1 and R2. Any resources like printer, cache memory, these are all your resources. Now, let us consider the scenario like P1, whenever if it wants to perform the task, it requires the resources R1 and R2. Also, P2, if it wants to complete its task, it requires the resource R1 and R2. Now, let us consider one scenario. What is the scenario is, let us consider, we will be representing uh, resources. Let us represent the processes with a circle, and let us represent the resources with a rectangle or a square, just for our understanding. So now the process will be requesting the resources, and the process will be having holding some resources. So all these things let us represent in a graphical form. Okay, so let us represent like this. Let us consider two processes in our example P no P1 and P2. Okay, two processes we are representing with circle. Okay, so this is P1. So this is P1 and this is P2. Now let us consider two resources are there. Let us represent the resources with square or rectangle. So this is resource 1 and this is resource 2. Okay, so let us name them. So this is R1 and this is R2. Now let us consider a scenario where now nothing is, no resources under any other's control. First, P1 requested the resource R1. Now what happened? P1, as the resource R1 is free, P1 got this resource and it has been given this one. Now P1, that means the resource R1 is under the control of P1. After some time, P2 requested the resource R2. Now R2 has been assigned by the operating system to the process P2. Now R1 is under the control of P1. So this can be called as control. Okay. Now, and this R2 is under the control of P2. Now, after some time, P1, if it wants to complete its execution, it requires R2 also. Now, what it does, it will request the operating system for R2 resource. So, let us consider this way of representing from P1 to R2 is your request. So, here what happens? P1 is requesting R2, but it can't be assigned to P1. Why? Because R2 is in under the control of P2. When the when the R2 can be released only when P2 completes its task. But suppose the scenario is P2, if it wants to complete its execution, it requires R1. So it will request the operating system for R1 process. But R1 can't be assigned to P2. Why? Because R1 is under the control of P1. When the R1 will be released, only when P1 will be completed. But when the P1 will be completed, only when it gets R2. But R2 is under the control of P2. P2 can only release when it completes its execution. That means here if you see there is a lock happened. What is the lock here is until and unless P1 completes, it cannot release R1 which is requested by P2, and until and unless P2 is done, it cannot release R2 which is requested by P1. So here it is in a deadlock, and throughout the lifetime they will never get their resources, requested resources, and they cannot complete their task and they cannot release the resources that they are holding. Such a scenario, if you are having such a scenario, then this situation is called as a deadlock situation. I hope you all are clear. Deadlock situation is a scenario where one process is holding a resource and requesting for another process which has been held by the another resource, and that process is holding the resource that is already in the control of the previous process. Such a situation is called as a deadlock. All right. So to understand this deadlock, so when can we say like a system is in deadlock? If this is the scenario happen, it is a deadlock. But there are some characteristics defined by the deadlock. So let us understand the deadlock characteristics. Okay, keep your heading all of you. Deadlock characteristics. Characterization. That means there are some set of conditions defined. If those conditions are satisfied, then we can assure, like we can say there is a deadlock. Got it? So make a note, all of you. So we will understand what are all these deadlock. What is this deadlock characterization? Okay. There are some necessary conditions to happen if if the system enters into a deadlock. Okay, what are all those conditions? The first condition is, make a note of all these conditions. We will understand one by one. The first condition is mutual exclusion. You have already heard this word mutual exclusion at the time of learning this critical section problem, right? We will understand what actually this one is. Mutual exclusion. Next one is hold and wait. Third situation which leads to deadlock is no preemption. And the last characteristic that has to be there is circular wait. Okay, so these are the four necessary conditions to be there to enter a system into a deadlock. Understand here these four necessary conditions. If these conditions are happening simultaneously, if these conditions are happening simultaneously, then deadlock may occur. We cannot ensure like deadlock will occur, but there may be chances like deadlock may occur if these conditions occur simultaneously. Okay, now what are these conditions? Let us see the first one, mutual exclusion. Mutual exclusion means you've already learned about mutual exclusion as part of shared resources. Do you remember shared resources? What we have learned there is if you have shared resources, the processes which wants to use the shared resources, the resources will be kept in a critical section. Do you remember in the critical section? And if one process is using the shared resources, another process will be blocked from using this critical section. That means only one process can make use of one resource at a time. Right? That means resources are not shareable. That resources are not shareable. That means if the resource is being under the control of P1, another resource P2 can't use these resources. Like one example I'll tell you, if resources are shared between the processes, then that may lead to error or inconsistent data. Like if you consider a printer, if you printer is our resource, then if you are giving it to two process P1 and P2, then the results we will get the printout in a wrong output way. The order of print we are getting may be wrong, isn't it or not? That means the printer is not shareable. Once the printer work is done by the process P1, then only it has to be given to the process P2. Got it? Then what happens? But because of this, what happened? It may lead to mutual exclusion, which it may lead to deadlock. This is mutual exclusion. One after the other, the resources has to be allocated. But because of this condition, it may lead to deadlock. What happened? Did you see here? This process has got the resource, but because it is not shared by this process P2, it has led to the, what is this one? Deadlock situation. Got it? So because of mutual exclusion concept, it is leading to the deadlock situation. But practically, avoiding this mutual exclusion is impossible. Avoiding this mutual exclusion is impossible practically. So we will not be checking always to avoid this mutual exclusion. We will see whether we could able to avoid this Holden weight or no preemption or circular weight, because avoiding this mutual exclusion is not possible. But mutual exclusion may lead to deadlock situation. Got it. All right. Now let us move to the next characterization. What is the next characterization is hold and wait. Hold and wait is nothing but one process is holding the resources and it is requesting for the other resources. That is what exactly happening here. What is happening here? Did you see here why the deadlock has happened here? The process P1 is holding the resource R1, okay, and it is requesting for R2, and process P2 is holding the resource R2 and requesting for R1. So because of this hold and wait, which where one process is holding some resources and without releasing those resources, it is requesting for another resource and it is waiting for those resources to be assigned to it so that it can finish the execution. But what happened here? Because of that holding and waiting, here it is R1, P1 is holding R1 and waiting for R2, and P2 is holding R2 and waiting for R1. What happened here? Because of this hold and wait, never they will get the requested resources, then they will be in a lock throughout their lifetime, which leads to deadlock. So this is one of the characterization of the deadlock. Okay, next one is no preemption. No preemption means you heard this word of preemption, no preemption at the time of CPU scheduling algorithm. What is preemption or preemption? Preemption is nothing but once if a CPU is assigned with one process, okay, if it is a preemption, there may be a chances like even without completing process, CPU may shift to another process. Right, it may shift to another process. But in case of non-preemption, what we understood is if CPU is assigned with P1, until and unless it completes the complete execution of P1, it will not be allowed to assign to another process. This is non-preemption. The same approach is applicable here in case of assigning the resources for our processes. What is that situation is, suppose here if there is a no preemption concept is there, that means if a process has been assigned to one resource, what is that? If P1 is assigned with one resource, until and unless its execution is completed, it will not release this resource. Because of that only we got this deadlock. Did you see here? What happened? P1 is holding R1, but it has to complete its execution to release this resource. But when it can release this resource? Only when it gets R2. Here it is what happened, no preemption concept has been applied. What is no preemption? Process will not release these resources until it completes its execution, because of which it has led to the deadlock situation. Right? Okay. Next one is circular weight. Circular weight is nothing but, observe this scenario. Same example can be applied here. Circular weight is nothing but one process is holding a resource. Okay. Process P1 is holding a resource and it is requesting for another resource. There is a circle. Did you see here? R1 is under the control of P1 and P1 is requesting for R2 which is under the control of P2 and P1 is requesting for R1. So did you see here there is a circle formed here. If such a kind of circular wait is there where P2 is waiting for R1 which is one wait and P1 is waiting for R2 which is a form of circular wait. So if such a scenario happens in our system then it may lead to a deadlock. Got it. So these are all the four characterizations or four necessary conditions that may lead to deadlock. But of all these four things, mutual exclusion is impossible to break. So in our solutions, in to keep our system from deadlock free, we will be checking there will should not be any hold and wait, there should not be any preemption, there should not be any circular wait, so that we can avoid our system from the deadlock. Right. So by checking these conditions, we can see whether deadlock is there or not in our system. We also have another approach, which is a graphical representation, which is called as a resource allocation graph that we are going to learn in our next lecture, which helps us in checking whether our system is in a deadlock state or not. This is the first way of checking whether a system is in deadlock or not. Second way is by using a resource allocation graph that we will see in the next class to check whether our system is in deadlock or not. With this, we come to an end of today's lecture. Let us all meet in the next lecture. Until then, thank you all of you.